Welcome to aminacademy.com. Let us go mini tour on engineering. In that, we'll discuss about history of engineering. Engineering is the use of scientific principles to design and build machines, structures, and other items, including bridges, tunnels, roads, vehicles, and buildings. The discipline of engineering encompasses a broad range of more specialized field of engineers, each with a more specific emphasis on particular area of applied mathematics, applied science, and types of application. The term engineering is derived from the Latin ingenium, meaning cleverness, and ingeniare means to create, contrive, devise. That means really the ingenium means the clever, engineer means a clever person. Definition: the creative application of scientific principles to design or develop structures, machines, apparatus, or manufacture processes or works, utilizing them singly or in combination, or to construct operate the same with full cognizance of their design, or to forecast their behavior under specific operating conditions, all are respect to an intended functions, economics of operation, and safety to life and property. Now let us discuss detail about history of engineering. Engineering has existed since ancient times, when humans devised inventions such as the wedge, lever, wheel, and pulley, etc. The term engineering is derived from the word engineer, which itself dates back to the 14th century, when an engineer, literally one who builds or operates an engine, referred to a constructor of military engines. In this context, now obsolete, an engine referred to a military machine, that is a mechanical contraption used in war, for example, catapult. Later, as the design of civilian structures such as bridges and buildings matured as a technical discipline, the term civil engineering entered the lexicon as a way to distinguish between those specializing in the construction of such non-military projects and those involved in the discipline of military engineering. An ancient Roman built aqueducts to bridge a steady supply of clean and fresh water to cities and towns in the empire. The pyramid in ancient Egypt, ziggurats in Mesopotamia, and Acropolis and Parthenon in Greece, the Roman aqueducts via Appia and Colosseum, Teotihuacan, and the Brihadiswara temple of Tanjavur, among many others, stand as a testament to the ingenuity and skill of ancient civil and military engineers. Other monuments no longer standing, such as the Hanging Gardens of Babylonian and the Pharos of Alexandria, were important engineering achievements of their time and were considered among the 7 wonders of the ancient world, including Taj Mahal. The 6 classic simple machines were known in the ancient Near East. The wedge and the inclined plane, that is ramp, were known since prehistoric times. The wheel, along with the wheel and axle mechanism, was invented in Mesopotamia, that is modern Iraq, during the 5th millennium BC. The lever mechanism first appeared around 5000 years ago in the Near East, where it was used in a simple balance scale and to move large objects and ancient Egyptian technology. The lever was also used in the Shadoof water lifting device, the first crane machine which appeared in Mesopotamia circa 3000 BC, and then ancient Egyptian technology circa 2000 BC. The earliest civil engineer known by name is Imhotep, as one of the official of the pharaoh Djoser. He probably designed and supervised the construction of the pyramid Djoser, the step pyramid, at Saqqara in Egypt around 2630 to 2611 BC. The earliest practical water-powered machines, the water wheel and water mill, first appeared in the Persian Empire in what are now Iraq and Iran by the early 4th century BC. Kush developed the Sakya during the 4th century BC, which relied on animal power instead of human energy. Hafirs were developed as a type of reservoir in Kush to store and contain water as well as boost irrigation. History of Middle Ages of engineering. The earliest practical wind-powered machines, the windmill and wind pump, first appeared in the Muslim world during the Islamic Golden Age in what are now Iran, Afghanistan and Pakistan by the 9th century AD. The earliest practical steam-powered machine was steam jack driven by a steam turbine, described in 1551 by Taqi al-Din Muhammad ibn Maruf in Ottoman Egypt. The cotton gin was invented in India by the 6th century AD, and the spinning wheel was invented in the Islamic world by the early 11th century, both of which were fundamental to the growth of the cotton industry. The spinning wheel was also a precursor of the spinning jenny, which was a key development during the early industrial revolution in 18th century. The earliest programmable machines were developed in the Muslim world. A music sequencer, a programmable musical instrument, was the earliest type of programmable machine. The first music sequencer was an automated flute player invented by the Banu Musa brothers, described in their book of ingenious devices in 19th century. In 1206, Al-Jazairi invented programmable automata robots. He described 4 automaton musicians, including drummers operated by a programmable drum machines, where they could be made to play different rhythms and different drum patterns. The castle clock, the hydro-powered mechanical astronomical clock invented by Al-Jazairi, was the first programmable analog computer. Water-powered mine hoist used for raising ore in 1556. Before the development of modern engineering, mathematics was used to artisans and craftsmen such as millwrights, clockmakers, instrument makers, and surveyors. Aside from these professions, universities were not believed to have had much practical significance to technology. A standard reference for the state of mechanical arts during the Renaissance is given in the mining engineering treatise. In modern era, the application of the steam engine allowed coke to be substituted for charcoal in iron making, lowering the cost of iron, which provided engineers with a new material for building bridges. This bridge was made of cast iron, which was soon displaced by less brittle wrought iron as a structural material. The science of classical machines, sometimes called Newtonian machines, formed the scientific basis of much of modern engineering. With the rise of engineering as a profession in the 18th century, the term became more narrowly applied to field in which mathematics and science were applied to these ends. Similarly, in addition to military and civil engineering, the field then known as the mechanic arts becomes incorporated into engineering. Canal building was an important engineering work during the early phases of the Industrial Revolution. John Smeaton was the first self-proclaimed civil engineer and is often regarded as the father of civil engineering. He was the English civil engineer responsible for the design of bridges, canals, harbors, and lighthouses. He was also a capable of mechanical engineer and an eminent physicist. Using a model water wheel, Smeaton conducted experiments for 7 years, determining ways to increase efficiency. Smeaton introduced iron axles and gears to water wheels. The application of steam-powered cast iron blowing cylinders for providing pressurized air for blast furnace led to a large increase in iron production in the late 18th century. The higher furnace temperature made possible with steam-powered blast allowed for the use of more lime in blast furnace, which enabled the transition from charcoal to coke. New steel making processes such as the Bessemer process and the open heart furnace ushered in an area of heavy engineering in the late 19th century. One of the most famous engineers of the mid-19th century was Isambard Kingdom Brunel, who built railroads, dockyards, and steamships. An Indian, we celebrate Engineers Day on September 15 as a tribute to the greatest Indian engineer Bharat Ratna Mokshagundam Visvesvaraya. He is one of the first famous civil engineer in India. Also, he is called as a father of engineering in India. The Industrial Revolution created a demand for machinery with metal parts, which led to the development of several machine tools. Boring cast iron cylinders with precision was not possible until John Wilkinson invented his boring machines, which is considered the first machine tool. Other machine tools included the screw cutting lathe, milling machine, turret lathe, and the metal planer. Precision machining techniques were developed in the first half of the 19th century. These included the use of jigs to guide the machining tool over the work and fixtures to hold the work in the proper position. Machine tools and machining techniques capable of producing interchangeable parts lead to large-scale factory production by the late 19th century. The United States Census of 1850 listed the occupation of engineer for the first time with a count of 2,000. There were fewer than 50 engineering graduates in the US before 1865. In 1870, there were a dozen US mechanical engineering graduates, with that number increasing to 43 per year in 1875. In 1890, there were 6,000 engineers in civil, mining, mechanical, and electrical. The foundation of electrical engineering in the 1800s, including the experiments of Alessandro Volta, Michael Faraday, George Ohm, and others, and the invention of the electric telegraph in 1816 and the electric motor in 1872. The theoretical work of James Maxwell and Heinrich Hertz in the late 19th century gave rise to the field of electronics. The later invention of the vacuum tube and transistor further accelerated the development of electronics to such an extent that electrical and electronics engineering currently outnumber their colleagues of any other engineering specialty. Chemical engineering developed in the late 19th century. Industrial scale manufacturing demanded new materials and new processes, and by 1880 the need for large scale production of chemicals was such that a new industry was created dedicated to the development and large scale manufacturing of chemicals in new industrial plants. The role of the chemical engineer was the design of these chemical plants and processes. The solar furnace at Odilo in the Pyrenees Orientales in France can reach temperatures up to 3500 degrees Celsius. Aeronautical engineering deals with aircraft design, process design, while aerospace engineering is a more modern term that expands the reach of the discipline by including spacecraft design. Its origins can be traced back to the aviation pioneers around the starts of 20th century, although the work of Sir George Cayley has recently been dated as being from the last decade of the 18th century. Early knowledge of aeronautical engineering was largely empirical, with some concepts and skills imported from other branches of engineering. The first PhD in engineering, that is technically applied science and engineering, awarded in the United States went to Josiah Willard Gibbs at Yale University in 1863. It was also the second PhD award in science in US. Only a decade after a successful flights by Wright brothers, there was an extensive development of aeronautical engineering through development of military aircraft that were used in World War I. Meanwhile, research to provide fundamental background science continued by combining theoretical physics with experiments. Now, main branches of engineering. So far we have discussed about the history of engineering. If you have done, please subscribe our YouTube channel.